and the end of chapter 2 was standard deviation. So I want to talk a little bit more about standard deviations, then we're going to get into probability, which is chapter 3. So I sort of talked a little bit about the way I look at standard deviation. I often call them steps. Okay, you're going to work. So I call standard deviation steps. So for example, if I have a distribution and the mean is 30 and the standard deviation is 3. What is one standard deviation up from the mean? 33, holy shit. Right? So if I put underneath here a 1, that makes sense, yes? Does anyone know what that actually is? The technical name for the number 1, what it represents?
I guess number of standard deviations.
From the mean, which is known as the
Right.
something score.
Z-score.
Z-score, I love it. So Z-score is the number of standard deviations from the mean to a data point. Does anyone remember, have I told you this yet? I've already told you one question that's going to be on every test. Every single test, I'm going to have this question.
The number of standard deviations from mean, right?
From the mean to the data point.
Right.
That's the Z-score. I'm going to ask you, what does the Z-score tell you? Or I might ask you, what would a Z-score of 2.7 mean about a data point? What would a Z-score of 2.7 mean?
It's 2.7 standard deviations away from the data point.
I love it. Away from the
Mean.
mean. Are you guys with me? Are you guys with me?
From the
I really want this to make sense. So standard deviation to me is how I make marks on my piece of wood. So we have a piece of wood. If I put marks at regular intervals, isn't that a measuring device now? Yes? I can measure, I can make up my own, this is the Jeff unit. So I can measure and go, that's 7.3 Jeffs, right? I can just make shit, because of course we made all of it up. Didn't we make all of it up? Did you guys know, I'm sorry, our measurement system is based on the measurements of one of the kings of England, one of the King Henrys. What we used for a foot was how long his foot was, right? Because of course kings came from the gods, so everything about them was amazing. And we're the last country on the face of the earth. There used to be 3, and now it's down to us. We're the only country on the face of the earth that still uses it.
There was like there was some African country that used imperial, right? So they dropped it.
Yes, it was shoot. It was Myanmar. Was it Myanmar and
Burma, Liberia, and America are the only places that still use it to this day.
yeah, but those 2, one of them switched, and the other one is about to switch, if I remember correctly.
I think it was Myanmar already switched in Liberia because it was formed, like from the US formed it, is in the process.
In the process, yeah. Okay, all right, sorry. That's all beside the point, I'm sorry. I'm really sorry, guys. I have a shirt that says I go off on a tangent, yes.
I, like, when we're talking about the Z-score and everything too, are we gonna be talking about when we get to like outliers and everything?
Yes.
The statistical
Totally.
significance, like it's outside, it's
Yes.
Z-score is this, so it's
Exactly.
not statistically significant.
So Z-scores basically drive a huge amount of statistics. So they're a little important. So the standard deviation tells me how to mark a tick mark. Doesn't it make sense for any given set of data, if I take the average distance the data points get from the mean, that kind of makes sense to use that as a measurement tool, as a tick mark on a ruler. So the standard deviation is the tick marks that make it a ruler, and then when I lay that ruler down, the Z-score is the measurement I take. So my standard deviation is like inches, and then I measure 2 people apart, and I say, oh, they're 27 inches apart. That's kind of like my Z-score. Yes?
Since it's away from the mean, right? That's what determines Z-score.
Yes.
So would you say, I guess, oh man, I'm kind of answering my own question.
Could you have like a negative Z-score?
Of course.
So could you have like a 0 Z-score if they're
Yes.
equidistant from the mean?
Yeah, in fact, the negative Z-score totally, because what's one step down? What's one standard deviation down?
27.
And that, of course, we have a Z-score of -1, yes? So what's the Z-score always for the mean itself?
0.
Because the mean is 0 away from itself, right? Okay, me stop for a minute. Yes?
So if you're asking for the Z-score between 27 and 33, would it be 0? Or would it be 6?
No.
Or the-
Remind me. Z-score is the number of standard deviations from the mean to a data point.
Oh, so it would be 6 because it's 2.
No. Okay, all right.
It wouldn't be a Z-score.
I can say how many standard deviations are from 27 to 33. 2 of them, right? That's not a Z-score though, because what's a Z-score tell you? How far from the mean to a data point. 2 data points, how far apart they are. I could calculate how many standard deviations apart they are, but that's not a Z-score.
Oh, okay.
I love it. I really want this to make sense. In statistics, if I wanted to prove to somebody, so let's say that Tylenol takes 20 minutes on average to cure your headache, right? And stat students are like, holy shit, this guy gives me freaking 20 minutes, way too long to wait. Are you kidding me? I got no time. I gotta do this homework. So we develop a new drug. Well, if our new drug, if we gave a sample of people our new drug and it took them 19 and a half minutes versus 20, is that enough evidence that our drug is better? Let me really make sure you guys understand. I take a sample of people. Tylenol is 20 on average. You with me? 20 minutes on average. We take a sample, we give our new drug, and it takes 19 and a half minutes on average. Do you feel like that's good enough to show that our drug is better? No. Why not?
It's not far.
It's not very far.
different.
Shit. So statistics trying to prove or trying to show evidence. You can't prove shit, but we can show evidence that something's different from something else. How do we do that? How far away? How far away is it? And that's what Z-scores do. They tell me how far things are apart based on a normal, natural kind of distance scale. What's the standard distance apart? So let me ask you this. So what if I have this guy? Wow. And he's got a mean of 30 also. But his standard deviation is 7. Does that make sense from the picture? Much more spread out now, right? Okay. So what's one standard deviation up for this guy? 37. What goes underneath that? 1, because it's one step up. You with me? I like it. All right. Let me make sure that really makes sense. So this is why there's several problems in the homework. There's one about batting averages and such, and they're like, relative to the team, who's better? Well, you calculate a Z-score. That's what Z-scores do. So if this is one class and it's a quiz and the average is a 30, oh shit, and I make it 33, and my friend, their average is a 30, he makes it 37, relative to our classes, we scored the same. Does that make sense? A little bit, okay. I like it, maybe. Okay. In fact, what's one more step up here?
36.
Have I even made it? It's 37, no.
44.
Yeah, you can keep going, add, another 3, yeah. If you add another 7, you add, okay. Let me stop for a minute. Okay, good. Now, there is something called an eraser. Oh, there. Oh, are one of these newer by any chance? This is about 20 years old. This is about, holy shit, this looks about 19 years old. Yikes. All right. Something called the empirical rule. Right. Yeah, I'm going to bypass that. That's probably a good idea. Yeah. If I have a distribution, well, let me ask you this first off, side note. Do you think it's possible to have a distribution that if I go one standard deviation up and one standard deviation down, I don't catch any data?
Yes.
Yes. Can you imagine what that would look like?
You just have like 2 sets of
Yeah.
extremes.
So I have, right? I'm going to bring this back later, this exact distribution. In the future, it's going to somehow relate to alternate universe Florida in our future. So we'll bring that back. But right now, this is just a quick visual. Do you see how if this is the mean? That kind of makes sense. That's the mean. If the standard deviation is just that, like that, do I catch any of the data within one standard deviation? Nope. The funny thing is, I'm not going to make this officially something you have to remember, but if I go out 2 steps, if I go out 2 standard deviations, I don't give a shit how you draw it. I don't care what numbers you use. If I go out 1 step, I could catch nothing, but if I go out 2 steps, I must catch 75% of the data. That should freak you out like a little bit. I don't care how you draw it. I don't care what numbers you make. I will always catch at least 75% of the data if I go 2 standard deviations down. If you think about it, that should only kind of make sense. What's a standard deviation again? What? Yeah. Yeah. There's a key word I need to hear.
How far away, how many standard deviations?
No, that's Z-score. What's the standard deviation tell you? You're like, dude, we just got Z-score down. What the shit? The standard deviation tells you the average distance from the mean to all the data points. So if I go 2 of those, if the average distance from the mean to the data points is a standard deviation, and I go 2 of them away, I'm going to catch some shit, ain't I? 1 step, they could kind of escape. But 2 steps, no, they can't escape. It is the average distance from the mean to the data points. I must catch some. Yes?
So, because I think I know where you're going with this, and I want to make sure I'm like concrete on it. If we're taking the average of 100% of the data, that's 50%. That's 1 standard deviation.
No. Stop right there. No.
Oh, 50% of 50%?
No.
You're catching the 75?
No. I like it because if I go 1 more step out, it would be 89%.
Yeah.
Which is really different. Okay. This you don't have to memorize. If I went 1 more step out, it'd be 89% of the data. I'm not going to make you memorize that. Okay. This is actually called, just because, it's called Chevyshev's theorem. I always call him Chevy Dude just because I can't remember his name. It's Chevyshev's theorem. Don't have to worry about it. Okay, don't worry about it. I just want you to realize what we're about to talk about is very specific. Let me say now, this was for anything. This is for any freaking distribution anywhere in the universe. Now I want to do, if I have a normal distribution. Can everybody real quick just draw a normal distribution?
It's a bell curve.
Well, yeah. I gave you 2 examples, but just draw a normal distribution. Okay. So depending on how you feel, it could look very different. I had a student once that just couldn't do it, and I said, just draw a triangle. You just need a quick visual. Triangle's close enough. Right. Just click that res down. Turn that resolution down. Let's do this. If I go 1 standard deviation up and down in a normal distribution, is there any way it's going to be 0%?
No.
Because why? In a normal distribution,
You have data.
I have most of the data in the middle, correct? Because it's got to start low, go high, and go low. Now, to be really honest, there's a lot more to it than that. But right now, that's good enough to kind of say it's approximately normal. But if I go 1 step up and 1 step down, if it's a normal curve, I will catch 68%. To be really honest, it's like 68.26%, but we kind of round it to make it easier to remember. You have to memorize this. So empirical rule says if I have a normal curve, if I go 1 step up and 1 step down, I catch 68% of the data. If I go 2 steps up and 2 steps down, no, 95%. Holy shit. Huh? What's up?
I'm very confused now.
Why? You were cool with 68?
I was even confused at 68.
Oh, okay, well, okay. Because otherwise I would be really confused why you're cool with one and not the other one. The word empirical means by observation. So what we did way back in the day is we had one of our computers that took up a whole room and we just fed it a bunch of normal distributions. And we noticed that it's always 68% within 1 standard deviation of the mean. So now that's just the standard. And actually now, later this semester, I will show you the formula that gives you the shape. And then you could use some advanced math to actually find the areas. Right? Some of you guys know some calculus possibly. You don't have to know calculus.
Just the area under the...
Yes, the area under any function is one thing calculus does for us, but we don't have to know calculus. We don't have to know it, right? And let me see if this makes sense. From my picture, and admittedly, my picture sucks. Every picture of mine will suck to some degree. and I'm okay with that. Does it look like there's a lot out here?
No.
Can anybody tell me, from what I've told you so far, exactly how much is out there?
5%.
5%, right? If there's 95% in, there's 5% out. So in general, what we do to kind of make it easier to find outliers is we'll say within 2 steps is usual, outside of that is unusual. So within 2 standard deviations of the mean, we call that usual. Outside, unusual. Okay. Does that, and again, that is a sort of arbitrary definition of unusual. I really want you to understand that. In fact, later this semester, we'll see how it changes in certain situations. You guys all with me? No? You're all like, I don't know, dude. That is a definition we've applied to describe what unusual is. Does it make sense? If something only has a 5% chance of happening, do you see that it's reasonable to call that unusual?
Yes.
I agree. Could it have been 7%? Sure, why not? Right? So it's a little arbitrary, but that's why I love statistics. It is so honest. It's like nobody's gonna come here, no alien's gonna come and go, this is what unusual is. You know, okay. No, we have to do it ourselves. It's all our shit. So again, you need to memorize this. Let me go one more step out. If I go 3 steps out, you will catch 99.7%. Again, I really hope it makes sense. A standard deviation is the average distance from the mean to any data point. So if I go 3 of those, I should catch almost all the frickin' data. They got 1 of those on average away. Maybe? Hello, and crowd goes meh.
What did you say it was? 99 point what?
0.7, yeah. Sounds like a soap commercial. All right. So let's make this a little more concrete. Average heights of American men. Let me just make this. Heights of American men. The average is 69 inches. And the standard deviation, I believe, is 2.8 inches. It's the last time I looked it up, yeah.
Can it ever get to 100?
No, that's an awesome question. Theoretically, this will go forever. So a lot of, can somebody be 1,000 feet tall?
I wish.
You wish, okay, sure, I don't know, man. I don't know about you, I don't wish.
I mean,
Walk out and you're like, oh shit, they're coming this way. Yeah,
Can't be 1,000 feet tall, but the tallest recorded man was 8'11".
there you go. I like it.
are you just asking?
Poor
like,
guy, 1 inch shy of 9 feet, sorry.
Are you just asking like pure technicality, like could someone be that size?
Well, we can get into the biology, but the biology and the gravity of Earth and all this kind of stuff would
I
say.
didn't mean that. I just meant like from like
Oh.
statistical, like technically, yes.
Yeah.
There could.
Theoretically, this goes forever up, this goes forever down, and I could have just said this: can somebody be negative 8 feet tall, or negative 5 feet tall? Can somebody be negative feet tall?
No.
No. Okay. Getting a little in the weeds, but that's okay. This is called a theoretical model, and a lot of our everyday experience fits it to within a certain amount. So it fits it close enough. So here's one reason why we call it a normal distribution. If everything goes as according to plan, most people should normally appear in the middle. What could happen with height?
Outliers.
You can have people that are, because people are varied, you can have it not be quite a normal distribution.
True. Why? Maybe they have a genetic condition, gigantism or dwarfism, right? Or maybe they their mom drank a lot of coffee or whatever, or something, right? All
Really
kinds
high
of things could
quality
happen.
whatever, yes, or something.
Maybe the kid drank a lot of coffee when they were 3. They were just stressed out. Okay. You guys kind of with me? maybe?
Cause like the 8'11" would be like 11 standard deviations outside the norm. Like he's way past.
Not
the-
quite 11, but I appreciate that.
Yeah.
So here. So we know that heights are normally distributed. How? By observation. So what goes right in the middle?
69 inches.
Yeah, the mean, 11. What's one step up?
71.8.
And how'd you get there?
2.8 plus 69.
Yeah. Somebody else tell me what's one more step up?
73.6. 74.6.
Yeah. Okay. And now I'll go one more step up. Somebody else. 77.4. Okay, guys. And now if we go one step down. Good. One more step down. What'd you get? 63.4. Okay. And then one more step down. 60.6. Sounds about right. Okay. Is everybody with how I constructed that? Give you the mean, I give you the standard deviation. I don't know why I put an X bar. It's okay. We'll just say X bar. Now, can anybody tell me? Let me introduce some notation. What's the percentage of American men who are between 66.2 and 71.8 inches tall?
68%.
My picture sucks, but that's okay.
68%.
Yeah, why is it 68%?
One step.
It's within one step away. I love it. Can anyone tell me, don't say anything, don't say anything, don't say anything. What percentage are more than 71.8? Don't say anything, think about it. I want to know what percentage is more than 71.8. Just think about it. Love you guys. So just to make sure everybody's thinking right, what's in here again?
68%.
All right. So who's got the answer? Yeah.
30, roughly 32%. 31%.
You're almost there. If this is 68, what total is outside?
32%.
So what's on that side?
16%.
16.
60% on each side.
Is that cool? Okay. So you can mess with this thing a little bit. You can kind of like break it up and see how much is on this side, so forth. So this will be, I really want everybody to see that. If this is 68, this is 32% total these, so this is 16. Why are they exactly the same? Because of symmetry. This picture is symmetric. Kick ass. And the mean cuts everything in half. Shabam. I mean, stop. Okay, okay. So, would you say that somebody who is 78 inches tall, would you say that they're an outlier?
Yes.
Oh, hell yeah. Right now, just to give you a little hint about what's going to happen in our future, right now, this kind of sucks because if I ask you, can you answer this question currently? What percentage of people are less than, of American men are less than 67 inches tall? Can you tell me exactly what that is? Yep.
You can. It's just going to take a minute.
You cannot. You cannot. You can't. Because all I know is freaking 1, 2, 3. Is this exactly 1, 2, or 3 steps?
No.
No. So in our future, we're going to have this chart where we can look up 1.28, negative 3.71. We can look up whatever the hell we need to and find the probability. Yeah.
Couldn't you take a percentage of the standard deviation that is and
No.
apply it?
Based because this is not linear. You can't apply some kind of a approximation like that. Okay. All right, guys. Okay. Yes.
Even though like it would just be a point on that graph, you wouldn't be able to just.
It's not a point on the graph. It is an area on the graph. It would be this area specifically. And it would, you could say it's more than 16%. Isn't it a little bit more than 16%? But you can't tell me exactly what it is.
So I set up an
Even then, well,
Even then-
you could do it because you'd have to use Taylor series, but
Okay.
yeah.
Okay.
All right. I really don't want to lose you guys. I want you with me. And I know right now you're all very concerned about what the shit's my work going to look like. Well, what I'm going to do, I could have a problem that says, here's the mean, here's the standard deviation, what's the percentage of people between these two? So what do? You set this up. And then you look at the numbers. If the numbers I gave you were 63.4 up to 74.6, what would the answer be? Percentage between 63.4 and 74.6. 95%. Because it's 2 steps up, 2 steps down. Okay, I like it. And why do I know those numbers so well? Because the bell curve has strict requirements. More than what we said, not only start low, go high, go low, but it's got a lot of other requirements about the curvature and all that kind of stuff. So I know exactly what percentage.
Are we ever gonna have something where we're concerned with 1 step down and 2 steps up?
Oh,
Or
sure.
we have like a total, I don't wanna say Z-score because that's not what it is, but a total range of like 3 standard deviations. We're just looking at from -1 to 2.
So if I had a normal curve, can anyone tell me, based on what Robert just said, don't say anything, Robert, hold on. Can you guys tell me what area is in between those two? So there's several different ways to figure this out.
95%.
Nope. It's not within 2, it's down 1 and up 2. So it's an irregular shape. So some of you guys are like, how the shit would I know? Let me ask you this, real quick. What percentage is between from here to here?
68.
So what's in here?
68.
No, what's in here?
34.
34. Yes?
Yes.
Half of 68. Is that cool? Okay. What's from -2 to 2? So what's in here? 47 and a half. Cut 95 in half, yes? So what's the total what I want? What would you do with those? Add those. Does that make sense?
Yeah.
All right, it's a little bit more than we have to do, but I mean, you totally could do it. It's just a matter of cutting things in half and putting them back together. There's several different ways to do this, by the way, but that's the way I thought of first. Okay, all right. So empirical rule. Within 1 step is how much? 68%. Within 2? 95. Within 3? 99.7. All right, I love it. Kick ass. Okay, so if I don't know it's normal, it could look like freaking anything. It could look like any freaking thing, right? In which case, I don't know shit. So a huge part of statistics is, how could we have tests to see, is it normal enough? Because if it's normal enough, I know everything about it, which is a really cool place to be. So a lot of what we're going to do later this semester is, what has to be true so I know it's normal enough that I can tell percentages? Yeah.
I was gonna say, could you take something with that graph or with the data that you're taking and basically make it a normal curve? Right, because
No.
there's a certain percentage of data like that has to be out, like when you find the percentages of data, and then can you kind of like force it into a normal
No,
behavior?
no.
Okay.
Good thought, though. All right. So that's the last bit of section 2.7 I wanted to discuss. So let's get into, actually, let me ask you, do you want to take a break now? You guys might be a little brain fried from the quiz and such. Or you want to take a break in a little bit? Let's do this. Let's take a break now. Come back, let's take 10:35. And then we'll do most of chapter 3 and then we'll call it a day. So take a break. You can go away, you can stay here, whatever you like. If you need to come up and see me for something, feel free.
So what is it with, like, Chevy Shed's work? Because I